Guten Morgen, Graz. Wie geht's? That's all I got from German. Like, even though similar as Kerem, I actually grew up just close to Graz, actually. I've been here in the past, to be fair. Just grew up across the border in Maribor. But yeah, I'm really glad to be here. Really glad to see that we have a local edition of the DevOps Days in the region as well. Yeah, thank you for having me. So, I think we're going to be staying more or less on track with Terraform, kind of continuing from the previous talk. And today, I want to talk a little bit more about kind of managing secrets and sensitive values in Terraform. Let's see if the clicker works this time. Yeah, we're right on track. Perfect. So, let's have a quick look first what the state of security is in general. So, you've probably all been kind of aware or you've seen the news about the cloud breaches and what's happening lately in the industry and how everything is quite insecure lately, or at least it seems to be insecure. So, as Patrick mentioned yesterday, as I was arriving into the Graz, there was a huge storm. Luckily, it was just a storm, but all my flights were kind of subsequently delayed. And I couldn't help to kind of think to myself, like, is this related to another breach or might be something else, right? And luckily, everything turned out all right. I only missed the dinner, but otherwise, I arrived safely. And like I said, there are quite a lot of breaches lately, and unless you have been living under the rock, you've probably seen something like that before. I actually found interesting, like there was a HashiCorp actually survey on LinkedIn. What are the kind of the biggest risks to your cloud infrastructure nowadays? And it seems like there are kind of two winners there. So the first one is security vulnerabilities, and the second one is misconfiguration, which I think, by my experience, leads to most kind of security leaks and breaches lately that we've been seeing out there. Just quickly, in terms of leaking secrets, I actually found quite interesting. There is actually a secrets pro research that has been done, and just to make sure that we are all on the same page, secrets pro is real. And what I found interesting about this research actually is that there is a very little overlap between secrets that are, say, stored in your SCM and secrets that are stored in collaboration. So I think that really reveals how big the scope is for leaking secrets and sensitive values across your code bases as well as your environments as well. So, without further ado, quickly about myself, why am I here, why I'm talking to you in the first place. Like I was kindly introduced by Patrick, my name is Marko. I'm a principal consultant at a company called the Scale Factory. We are small, not that small anymore, we were actually acquired last year. So we were part of a bigger group, 1010, but we are AWS consultancy based in London, fully remote. We mostly kind of work with SaaS companies or SaaS adjacent companies. We are also kind of, as being acquired, kind of working with other cloud vendors as well, not just AWS. But my apologies for everyone that's not working in AWS space. All my code examples later will be in AWS because of that. But you can easily apply those principles and concepts to other cloud providers as well. I have an ops background. I started as a system engineer, kind of moved my app to cloud architecture, and then later on to cloud consultancy, where I work now. Currently, I work more in an IC role, but I used to manage people as well, so I kind of wore different hats throughout my career. Throughout that journey, I see many things. I think my privilege was working with all different customers across different industries. So that gives me, I think, quite a unique view of how things work across different sectors using SaaS products in cloud. I'm also a HashiCorp ambassador, Open UK ambassador, and AWS community builder. So you can definitely see me in those communities, speaking out, hanging out with the communities, as well as being present. And I'm also a big fan of automation, simplifying things, hiking and traveling. So that's another reason why it's good to have, another good reason why to be in Graz, to be fair. Such a beautiful day. Let's move on. I would assume, like, I won't assume. So a quick show of hands. Who is familiar using Terraform? Perfect. This talk is definitely for you then. If you're not, you might still find it interesting. So very quickly, just kind of set the baseline, how the Terraform workflow looks like. So on one end, you would usually have users who write Terraform code, and on the other hand, you would have cloud infrastructure or any kind of SaaS product with API endpoint where you want to apply that configuration to. And how it usually works is it's kind of a three-step process. So firstly, you kind of initialize your state and configuration, and then there are a couple of steps that are very typical, which are plan and apply. So in the plan stage, you kind of get the intent of what you're going to change, how that compares to the current state of the world, and then we apply stage, as it says on the tin, just applies your changes. In order to kind of achieve that workflow, Terraform using something called Terraform state, where it kind of stores your kind of reflection of your reworld, and it's always being compared to your changes in the configuration. So as soon as you apply something, it can give you a really nice kind of a diff plan of what's going to be changed before you actually make the change. So if we kind of keep that in mind and move along, maybe before we look at the kind of security footprint or like exposure points, let's ask ourselves, like, what are secrets in Terraform? What can we store there? So you can store anything from API keys, passwords, or any kind of connection strings or something like that that you would need to connect to a secure data source in the background. If we look at how we usually run Terraform, there are basically kind of three workflows, or we can break it up at least in three. The first one is you can use CLI, or use some kind of wrappers around CLI and just either run it from your laptop. I really hope you don't do that. Or you can stick it in a pipeline, like we heard from Eugen before. You can have an automated pipeline in something like GitHub Actions, or even something like a managed product, such as HashiCorp Terraform Cloud or Atlantis. Doesn't really matter. And the third one would be, that's actually the third one. Sorry. So the third one is kind of a SaaS offering. So the comparison here is you can self-manage your pipelines, or you can just go with the vendor and say, it's not our core business. Why we would want to invest our engineering into that? Just go with what's available off the shelf. If you keep all that in mind, just look at what the most common exposure ports here are. So where can you see the kind of secrets leaked out is, first of all, you can obviously have them in code and in your repository. Second of all, you can actually have them in your execution environment. So if you self-host your pipelines, you need to make sure that that's kind of kept secure. And then the third one is Terraform state. I will get into details a little bit later, but just keep those three in mind for now. And again, risks are always based on your security parameter as well as the responsibility, the way how you kind of slice and dice that in terms of your roles internally in your company. So let's quickly move along. So let's look at the first kind of potential thing to keep in mind when you're running your Terraform. So you can have secret store in your configuration, which is probably the most obvious one. Everybody would think like, sure, that sounds like a bad idea, right? And I would probably not recommend doing that, but you would be surprised how many times you still find something like that in there. You can do a few preventative measures, how to kind of avoid kind of sprinkling that around or kind of leaking it around your code base. So you can do any kind of Terraform repository scanning. Again, you don't have to use HashiCorp tools, but they have a really nice tool called Radar, which can kind of scan your Git repositories and kind of point out all the potential security leaks that you might have. You can do like manual code reviews or kind of raise the team culture awareness around it as well. If you still feel like you want to store that in the code, there is a solution or multiple solutions how you can achieve that. Again, I wouldn't necessarily recommend that. There is GitCrypt. There is something called SOPs, secret operations, where you can in place encrypt your secrets and still store it in Git. So it would be just unreadable to the human eye, but you can decrypt that with your private encryption material. you can dynamically inject those from the environment. So for example, instead of storing that in the code, you can just inject that through the variables or just execution environment as you go along. And then the third one, which is probably, I guess, the best one of all those, is store them externally in a sealed environment. You can use something like Vault or a secrets manager. Google and Azure have a similar offerings for secret storing as well. I think we heard that before as well. So just pick one of those and just dynamically read that from your code rather than store it and hard-code it in there. And again, you can use something like randomization to kind of reduce the risk as well. Going to the next one, you can, you definitely need to watch out for outputs and audit trails. So something that's usually kind of overlooked, I feel, where people kind of forget about logging and emitting things in the pipelines that can still emit secrets. And again, the responsibility for that may differ regarding how your SecOps lies within the organization. But keep in mind that it's important to keep the logs clean and audit trails clean of any kind of PII material. I think Karen mentioned that in the morning, like we've been, I guess, ignoring GDPR for quite a long time now. And again, Terraform 014, which seems like years ago, has introduced sensitive values. So you can mark values as sensitive, and that would prevent them to being emitted. So they're kind of masked in your pipelines. Some of them are automatically marked as that in the provider, but just keep in mind that that doesn't equal encrypting those values. It's just masked. Moving along, the third one is actually 2.5. The reason why I'm calling that 2.5 is I think the keynote quite nicely covered all those points, so I won't go into too much details. But for example, keep in mind as you're running your Terraform workload, protect your execution identity. So for example, if you're using execution role or, I hope not, long-lived keys, make sure that you rotate it regularly and that you store it accordingly. All the best practices apply here as well. So please don't use short-lived keys. Make sure that you're safely storing those credentials and the pipelines are secured as well. And making sure, and please use the least privilege approach as well. So limit the access to the execution environment, to just the entities that need so. Obviously, I cannot go past the generative AI now. There's going to be a roundtable later, I believe. But just to kind of quickly go through those, again, make sure data can leak through your training data as well. Make sure if you're using tooling that helps you generate Terraform code, to make sure that you review that. There can be leaks coming through there as well. Same applies for any kind of RAG as well, because with external data sources, that can be kind of ingested from the external sources and not something that people normally think of initially. And we all know that the S in the MCP stands for security, right? So again, keep that in mind. Right. And the last but not the least, the most important thing I would say is make sure that you're keeping your Terraform state secure. What I mean by that, specifically, as you're probably aware, if you're using Terraform, the state is just a plain text YAML file. So nothing is encrypted there, and everything that you have in code or that you're using in your code is stored there. So it can actually, like I said earlier, compare your real infrastructure to your configuration. So what are your options really here? There are probably like 3 options here. So the first one is you can use something called native state encryption, not something that's available in the vanilla Terraform, but there are third-party Terraform forks that can do that, such as OpenTofu. Not necessarily what I find like a good solution. I know I'm probably biased because HashiCorp ambassadorship, but I do think it's not the best solution because it makes it really fragile, and if you lose the key, you kind of lose, access to your Terraform code, which is quite annoying, especially if you have all the infrastructure provision through that. The second one is storage encryption. I really hope that wherever you're storing your Terraform state, you are encrypted in that storage in transit as well as at rest. So for example, if you're using something like S3 bucket, nowadays, you cannot even turn on the encryption. So AWS is making sure that you are storing that safely anyway. Then there are two new things that I really want to focus on today, which are ephemeral values and resources and write-only attributes. I think those are probably much better approach than what I mentioned earlier, like native state encryption. Specifically because the ephemeral resources make sure that if using those resources, those are never written to your state. And you can use ephemeral resources as well as the values. Something to keep in mind, that has been available only from Terraform 1.10. And again, it's not just the provider, it's also it's not just Terraform core, it's also the provider. So you need to use, for example, AWS provider that is higher than 585, just because the ephemeral resources are actually separate objects. They're not the same objects as normal resources. So you need to have support for that. And then we have, and then they come with some restrictions, which I will dive into a little bit later. And then there are write-only attributes, which are expansion of the existing resources. And you can use so-called write-only attributes, which you can only write to. They're never stored in state. But it kind of eliminates that security risk of your state leaking, or somebody has unauthorized access to it and reading those values up. So, as I said earlier, there are a few ephemeral resources out there. I kind of list out the most popular providers, such as AWS, Azure, Kubernetes, or Google. As you're going to see here is there are few of them, not a lot. Like I mentioned earlier, the reason for it being it needs to be re-implemented. It's not just automatically you just turn on a flag and say it's ephemeral. It needs to be re-implemented as ephemeral resource. Like I said, what's special about it is it's never written to a state, as well as all of the lock-unlock operations are actually done in memory, so you're never storing anything on disks anywhere. So that's what it makes it really powerful, actually. But again, it comes with some limitations that we will get into later. So for example, the use cases for it are providers, locals, ephemeral variables, and provisioners, for example. Quickly on the write-only attributes. Specifically for AWS provider, we have listed a couple of them here. So for example, you have SSM parameter value WO, or for example, like for the database instance, you have password WO. They're usually exclusive with the plain text attributes. So for example, you can't use password WO with the password. It just kind of excludes itself. And they kind of complement the functionality of the ephemeral values, which we will see just in a bit. Here we go. Who's ready for some code? I mean, I have plenty more slides if you prefer that. Right, let's dive into some code examples really quickly. I would normally do that live, but that wasn't an option for this conference. But bear with me with some static slides. You have to trust me that actually it's how it works. So if we look at the first example, which I called ephemeral 101, is you might ask yourself, like, OK, Marko, you've been saying to us like all those cool features about ephemeral values and resources. How do you use that? Quite simply, actually. Here we go. If you want to mark a variable or an output as ephemeral, you just simply say ephemeral equals true. And it's automatically marked as ephemeral and never stored to state. Similar, if you want to use ephemeral resource, what do is you just, instead of resource, you say ephemeral. And the syntax stays the same. For example, like secrets manager, secrets version, and the name of it. And it has the same meta arguments as the normal resource. So quite easy to use. And then in this example, you can see we're using it in the Postgres provider as a password attribute. And just kind of feed it in directly. So one would say, pretty easy, right? Oh, that's one-on-one. Let's dive in more. So let's kind of move to the next example, which is a little bit more complex. So the first slide is just kind of showing you what we're defining here. So we have few resources. We're using secrets manager, secrets version. We're using ephemeral value for the credentials. And then keep that in mind as we jump into the next example. I don't have the whole code here just because it wouldn't fit in that slide, and I just want to focus on what's important for this presentation. So if you look at this, what we're doing here is we have a MySQL provider, and we're defining a database instance in AWS, very small one, GP2, nothing special. And normally, what people would normally do is you need to set an initial password, and people would just feed it in from the variable, right? Which is a variable, initial password value, here we go. Again, like I said earlier, not a very good practice. So what you would do next, you would probably say, fine, okay, you told us before you should use, you should store the secrets in an external system and just kind of feed it in. So what you can do is just use an AWS secrets manager in this example and just, query the secret that we have created earlier and just use that value as an initial password, which is all fine. We don't have any passwords in the code. Everything is clean. But the problem is, if we look at the state now, what you're going to notice is, like I said earlier, it's just a plain JSON file. You're going to see the password field actually contains the secret value, which, again, you're normally protecting the state. But to kind of eliminate the risk of somebody, having unauthorized access to the state to read it, have access to all the secrets, you probably want to avoid something like that. So, as I've been explaining, ephemeral resources to the rescue, right? So normally you would just say, fine, we're just going to replace the password with ephemeral secrets manager, right? And that would just work, right? It wasn't a rhetorical question, but OK, tough crowd. So if you would do something like that and run your Terraform, it would actually error out. So if you remember what I said earlier, kind of more in a passing by, is the ephemeral resources actually do come with some limitations. So you just cannot use an ephemeral resource with a normal resource, just because they have kind of a different security model. And if you would use it in this way, you cannot avoid storing that value actually in the state, because the normal resource would actually store it in the state. So it kind of beats the purpose, so to speak. And Terraform is kind of intelligent enough to kind of give you a heads up, saying you cannot use it like that. It's because it would actually be persisted to the state. So if we jump to a simpler example, just because I couldn't fit everything on a slide again, is if you want to use an ephemeral resource in normal resource, what you can do is you can actually use so-called write-only values, because those are never stored to the state as well. So in this example, we are actually having an ephemeral resource for the secrets manager, and we are actually using that to store a secret in an SSM parameter, which is a normal resource. But in this case, we're using a read-only value. Sorry, write-only value. My mistake. And then again, because this is never stored to the state, the only kind of mechanism you have in place to kind of detect the change is, obviously you cannot detect the change if somebody changes the password. There is an additional attribute here, which is called a value, WO_version, which is literally just a simple numerical value, which when you change it, it will write the value of the password again. So it doesn't have to be incremental. As long as you change it, so for example, we could change it from 1 to 2 and then back to 1, it will still detect the change and just write the value again. But in this case, if we look at the state, as you're going to see here is nothing is stored to the state. State is empty. So for example, the value is empty, the value WO is null, and we're only storing the WO version here. So this is the only thing that we're kind of triggering the state updates on. Cool. Right. How is that? Make sense so far? OK, I hope so. Let's wrap it up. I know we're slightly behind the schedule with the program. I want to keep it in a half an hour, and I think we're actually doing quite well. So to kind of wrap things up, first of all, remember, security is hard. We have to admit to ourselves, it's not an easy task. It's still hard to achieve. if you're going to take anything away from this talk today, maybe remember about ephemeral values and ephemeral resources. Definitely try to use more of those. And there are 3 things that I want to leave you with. First of all, protect your crown jewels. So make sure that you are avoiding hard-coding hard-coding your sensitive values in the code. Make sure that you sanitize the outputs, and definitely protect the state. And like I said, use ephemeral values and resources. Second of all, definitely fall back to multi-layer security. So use all the tooling that's available to you, like code scanning, analysis, static code analysis, and just do the defense in depth. Like, don't get fooled by, oh, we're doing 1 layer of security, that's enough. It usually kind of pays off in the future if you're doing defense in depth. So if one of those are kind of defenses are penetrated, you are still kind of secure to a certain level. And then, last but not the least, don't forget, it's not just a technical problem. It's also a people's problem. So make sure that you educate your people, make sure that they're aware of the risks, aware of the tools available to them, and maybe try to avoid the security tier 2. That's kind of my last thing to add to this one. And to leave you with that, like the famous philosopher Werner said, dance like nobody is watching, but definitely encrypt like everybody is. Thank you. I'm ready for questions or anything else.
Voila, Marko.
Oh.
Thank you so much for a great talk. Are there any questions from the audience? Don't be shy. Finally. Be quick.
Thanks a lot. Question is regarding the ephemeral values. So you switch it on and off. You had there a version also down there. And I'm thinking like for the keynote, the first keynote, if I'm making a version like 1 point and incremental, and the other parts, the more like a Boolean, like 0 and 1, I can track when I've put in my new secret. So is this a way to go? What do you think about it? Because then I can say, okay, in version 17, I switched it on, and I had the new secret from my key value store. For my secret store in it.
Right. I hope I understand the question. So if you're asking if is the way to go to change the, I think we had like the WO value, right?
Yeah.
If you change that, yes. The whole intent is just to detect the change. It doesn't really matter what the value is. So you can go up, down, random numbers, doesn't matter. You can use any value. But this is the only way how Terraform can actually detect that you have changed the value, just because it's not written to the state, so it doesn't have anything to compare it to.
Yeah, but I would use a second version part to know when I changed it, so that I know, okay, now I injected a new secret there.
Yeah, you can definitely do that. Okay. You just have to remember it's never stored to the state, so you have to use something externally to that, yeah.
Thanks.
Yeah, no worries.
Any further questions for Marko? Yes. Oh, sorry.
Hi. How do you suggest we manage state files automatically, considering that we have stored passwords in them, and we want to protect those passwords, and those passwords are being regularly rotated automatically as well? But how do we keep the state files synced with those changes and secure? If you have any guidelines or suggestions.
I mean, I don't think there is only one right way of doing it. That would be my approach. Like, I'm a consultant, so I would probably say it depends. Like, it's the most common consultancy answer you would get. But the recommendation I would have is make sure that's encrypted, so you're not storing it in an unencrypted backend. So the backend can be anything you want. It can be S3 bucket. It can be a SaaS managed solution such as Terraform Cloud. Doesn't really matter. Like, if you ask me, it doesn't really matter where you store it as long as it's encrypted. And like I said earlier, make sure that you have defensive depth. So not just encrypting the state, but make sure that you can avoid storing any secrets in the state if you can as well. I know that's not always possible, but if you can, definitely try to do that. Does that make sense? Does that answer your question?
Yeah, thanks.
Yeah, no worries.
Thank you. And final.
Hello, thank you for your talk. I try to wrap my mind about automatic secret rotation. You gave the example with the secrets manager from AWS and the version attribute. But how would the system detect if the secret is rotated in secrets manager?
Like I said, there is an attribute which is called value, which you need to change to detect that. But if you're referring to, for example, like write-only value attributes, right? You cannot detect the change because nothing is stored in the state. So it wouldn't know that you changed something externally unless you bind, let's say, if you have like you bind it to maybe to a hash of a value, and you bind that to the version attribute. Maybe something like that could work, if that makes sense.
You would have to retrieve the hash from secrets manager and
For
give it as a
example,
version.
yes.
Okay, thank you.
Yeah, no worries. I'll be around, so if there are more questions, feel free to grab me outside. But Dankeschön.
Thank you so much, Marko.